Hey all, welcome back. Working on the mill again. And first thing, I got my disconnect box all mounted up nice and pretty where it should go and the wire routed. And just because I missed the janky, I made this nifty-difty little extension cord out of a European terminal block to get over my bench to test my snowbank motor. So let's flip this on, let this warm up. First thing I noticed when I put the new bearings in, if you can hear that, there's some rock in the shaft. I know it's not between the shaft and the bearings because I had to push those on in order to get them in place, so it's the bearings to one or both of the bell housings. Now if I start this up, you'll hear why that's an issue. Thump, 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 thump. You know, even at the original frequency, it's bad. For whatever reason, at twice the original frequency, it sounds pretty good. So I don't think it's out of balance. More than likely, it's loose. I haven't really figured out how I'm going to fix that yet, so I'm going to take it apart, see what my options are, and go from there. Also, I got my new replacement wire entry box modified and put on, and then just a regular plate will go to the front. So if I can fix the knock and the wobble, I should be good to go. Okay, so I tore the motor all the way back down again and started playing with the bearings and noticed, I think I found the source of my wobble. So first off, the shaft end of the motor, if I flex it as far as I can, I get a little over 25 thousandths, so 27, 28 thousandths. Now if I do the same thing on the tail bearing, a sec here to get set up. I have 150, almost 200 thousandths of slop. I mean, kind of obvious something's up with that bearing. So get this out of the way. First off, take this one off. If you notice on this end, you probably totally can't see it in the video, but you probably can hear that. The washboard texture from when they machined this pocket is still all the way across the surface of that bearing cap, where this cap, I didn't notice it initially, it doesn't look like it was spun. I mean, there's no circular scratches you normally see when things spin, but there's the washboard pattern there, there's a little bit of a lip, and the center section is just perfectly smooth, and then a little lip here. I think what happened is when this thing was originally in use on that gearbox, these two shafts went like this, there was a bearing way out here that held up this end of the shaft, no bearing here, and then this was the first bearing on the output side of the gearbox. Now right here was a great big huge worm gear which drove another gear to the output shaft. I'm wondering if something, there was a mushed teeth, something was machined wrong, who knows what, where this would get out of round. So as it turned over, there was a high spot that would push up on this point. Since this was fixed and this was fixed, it would cause this to bend, from straight to bent up like that, then bent down like that, then bent up like that. And that caused this bearing to wear this groove in the back cap. Now, the main reason I came up with that theory is looking at the shaft here, right here, it's sort of smashed in. So, don't know if that's really what happened. Like I said, when I took this apart, the rear bearing was not frozen. I don't see score marks. But anyway, how am I going to fix it? So my current theory in life, this is a 4/1000 shim, is to shim the rear bearing sort of like this. I mean, right away you can see that's way more not secure, but unsloppy, less sloppy. I don't know what the term would be. And now if I do that same check, I get about 25/1000. Now I'm not quite to the point of giving up my shim here permanently as a spacer for this bearing, and also it's not quite long enough to go all the way around. So I'm going to go find myself some shim stock in the form of pop cans and see if I can cut some sort of little shim to go in there and shim this bottom bearing and bring this motor back to life. Okay, made up a quick shim here. I found a A&W root beer can. It's basically 4.3 mils thick, which is a little bit thicker than my 4/1000 shim here I was using before. So I cut a small ring of it and put it in here with a little bit of blue Loctite, and now I'm just going to button the whole thing up. I also coated the outside of the bearing with some oil, so any Loctite that squishes out, don't forget your wave washer. Any Loctite that happens to squish out the ends won't stick to the bearing, so that I can actually take this thing apart someday if I need to. And it just goes on like that. This goes in like that. So I'm just quickly setting this guy back together so I can check to see if I fixed my problem or not. I'm not going to even screw on the end caps right now. I'll get everything lined backed up and screwed together after I prove that this fixes the problem. That's all seated. Wiring's all still hooked up. Let's give this some juice. So first things, that thump 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 from shaking the shaft is gone. Turn this all the way down, start her up. There's a little bit of a thump still. That might just be bearing noise, or the fact that I don't have it all screwed together. Overall, pretty good. That noise right there is it's out of balance because there's a retaining ring to hold this upper bearing in, and I didn't screw it in. So, the fact that it vibrates is not concerning. The good news is that massive thump, 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 thump that I was getting at low speeds is completely gone. So with that, I think I'm going to try and put the sucker all the way back together. Well, just when I thought this was nearly done, I found another problem. When I was going to put the motor screws back in, I had a hell of a time getting one of them to thread in. So took it apart and found out two of the holes were basically all stripped out. The other two were in pretty good shape, so I just left them be. So what I ended up doing is making some poor man Gila threads, if you can see that guy there. So it's 1032, which matches these bolts on the inside, and 1/420 thread on the outside. So to prep the bell end, first thing you do is you drill out the bolt hole and then tap it for 1/420. And then you take a 1/420 bolt and then drill out the center and tap it. the OD of a 1032 bolt and the ID of the grooves of a 1/4 bolt are very, very, very close. So to support it while I was doing the machining, you put a bunch of nuts on the outside like this, and before you remove it from the chuck, run a screw, a 1032 screw down the center, so that then you can remove the 1/4 bolts without shredding the helithread. More or less, all these threads here are disconnected from one another or have a very, very thin web of metal between them. So, you can just barely see where they're split apart. So, just like last time with the bearing shim, I'm going to clean both parts with acetone to get any of the oils off. When I drilled and tapped this guy, I did it dry, so that should be relatively clean. I could run a Q-tip full of acetone in there, but I'm not caring that much. This guy, I used a lot of cutting fluid to get it drilled and tapped, so I know he's full of goop. First thing I'm going to do is turn the screw back till it's just flush with the end of the bolt, and then coat this sucker with Loctite. Concentrating on the end of the bolt because the top more than likely is going to have to be cut off. Alright, that's a good amount of Loctite. Now you take this whole thing and just thread it in. And take a small wrench. Turn it in. And at some point here, when it bottoms out, it should split. Oh, there it went. So you heard that crunch, and then you feel the difference. What I just did was broke the threading because it was so thin. Now, with any luck, I can pull the center screw out. Well, that's what I didn't want to do. When I started to pull the center screw out, the bolt came with it, so I gotta turn it down in. Forward the bolt. Oh, maybe it didn't split. Oh, it started to split, I just didn't turn it far enough. Okay, try that again. See, there it split. Just keep going. Center bolt out. There. Now it's two pieces. Almost two pieces. So there you can see where the thread snapped when I cranked it all the way down. And you look in there and you can see the helicoil, which is probably a brand name, thread repair, stuck in the bell housing. And with any luck, when the Loctite cures, that will never come out again. Let's see my screw. Wipe up the excess Loctite. So I happened to luck out. There was enough metal here to over tap it to 1132 or to quarter 20 from 1032s, and it didn't come out the sides. So now take one of these guys and it should just thread right in. So there you go, all fixed up, ready to go. And now back to reassembling the motor. It's all put back together. I don't have that nasty shaft rock that I had before, even if I get, yeah, way better. So let's give her a spin and see what happens. So there's still a little bit of a tick in it, but not very bad. And there we're at 60 Hertz. Pretty good. And there's 120. Now it has that like bearing failure whine, but both bearings are brand new. They haven't been abused. There is a fan in here, so I'm wondering if that noise is from the fan. It wasn't a very good fan. It was just sort of this plate with little fingers. I think it's mostly meant so that if this was hooked to a pump and water came spraying back and got through all the seals, it'd get flung to the outside instead of getting into all the windings. But I think this is about all I can do to this for now. That said, it was a $20 motor, so if it runs for a few years and then dies and I gotta put a new one on it, so be it. But for right now, it's good enough. So when I picked out this motor, I did a bunch of measurements to make sure it would fit. You know, checking diameter, where these plates and where the base plate and the connection box was, because the existing motor spins to tension the belts. It's an offset cam. Apparently the one thing I didn't check for when I was measuring everything was the length. And as you can see, this new motor is about, what, an inch longer than the old one, which means it's not going to fit, because I got to put at least a 1/4 inch, if not a 3/8 inch plate on here to make an adapter to go from this bolt pattern on this motor to the smaller bolt pattern which goes between this motor and that top plate. So that was kind of fail. But I might luck out. I can put a spacer here to lift this plate up, and if I lose this bottom pulley, which is a 1-to-1, or is that the step up? That looks like the 1-to-1. Then I think I can make everything fit and still have the top cover go on like it should. Since this motor can run up to twice as fast as this motor, I really shouldn't need the 1-to-1. What is that guy? 1-to-1 is D. So anything that starts with D. So I'd lose 450. Or, you know, if I only could run at 60 Hertz, I'd lose 450, 1450, 2140, and 3000. But I'm probably going to gear this to the middle speed and then use the speed control to get, you know, the whole range, or use a couple of the speeds in the middle to get the whole range. So, you know, CA is 2350, which I can still do once I modify that pulley, but double it and you get 46 or 4700 RPM, which is way faster than I'm ever going to run anything. So even with the snafu, I should still be good. This does mean I need to make spacer blocks for here, this adapter plate, and then I'm also going to have to cut this guard down. It goes over top like this, and it's going to have to raise up. Or Ooh, I might be able to just mount it on the bottom. That would work. So there's some things I gotta figure out and do yet. But I think for now, my motor escapades are done. I still have not gotten my fuse holders for this guy, and I'm almost done with the wiring diagram. I'll get that posted. I got one more thing I want to try out before I post that, and then I'll start laying this guy out and taking more video.